Hello everyone, how are you all of you? I hope all you were doing good, okay? And keep studying. Now, see, today's first topic is the Frank-Lewis adsorption isotherm, okay? Frank-Lewis adsorption isotherms. To know about the adsorption process, how the adsorption is carrying out with respect to particular temperature, particular adsorbent, okay? We have to know a well-known theory about the Frank-Lewis adsorption isotherm, which gives an empirical relationship between the quantity of gas adsorbed, okay, by per unit mass of the solid adsorbent at a pressure and at constant temperature. See, the empirical formula which is given by Frank-Lewis is the based on particular temperature. That means in a particular temperature, the Frank-Lewis isotherm is a particular graph. Okay? If we change the temperature, then obviously the adsorption process or the graph is, that means isotherm graph, may vary. Okay. Now see, the empirical formula is x by m equal to k p to the power 1 by n, where n is greater than 1. Now what is x? Where x is the mass of gas adsorbed on mass of gas adsorbed, where x is the mass of the gas adsorbed on the mass m of the absorbent. Okay, that means x amount of gas is adsorbing on the substance which has the mass of m, okay, at a pressure p, and the k and the n, this one n is a constant which is depend on the nature of the adsorbent and adsorbate, that means gas, which is in a particular temperature. Okay, all of you please ignore the background sound of rain. Okay, so much rainfall is going on, no? That's why you may hear the background sound of rain. So please avoid the sound and try to listen what I am saying. I think if you use headphone, then you can hear what I am saying or what I am explaining properly. Okay? Yes. This is the empirical relationship of Frank-Lewis adsorption isotherm, where x by m equal to k p to the power 1 by n. Okay. Now we will see how the graph varies. Now see. Now if we see the graph between x by m and p, then we can see at a particular temperature, remember, at a particular temperature, as I said, the graph should vary. When the temperature is higher, we can observe this type of curve. Suppose this curve is the at temperature, suppose 273 Kelvin. At lower temperature 244 Kelvin. This one is at very low temperature 195 Kelvin. That means we can say that at higher temperature the adsorption is low, because x is the mass of gas adsorbing on the mass of the adsorbent. That means in this way the adsorption is increasing, here pressure is increasing. But at a particular temperature, suppose 273 Kelvin, the adsorption is this much. But in some lower temperature, 244 Kelvin, the adsorption is a little bit higher than this one. And further, if we just decrease the temperature, that means 195 Kelvin, the adsorption is more higher than the previous two. Okay. Now what can we say from the graph? From the graph we can say. So statement we are writing from this graph. As the temperature increases, the adsorption, see, as the temperature increases, the adsorption is decreases. Adsorption decreases, isn't it? Next, now what do you know? We know x by m equal to what? K p to the power 1 by n. Now if we take log of this equation, it becomes what? It becomes, if we take log on both sides, it becomes log of x by m equal to log of k p to 1 by n. This one, suppose we have taken as this one one quantity, this one is another quantity. Log of a plus a into p formula we can apply, no? Next, I'm just rubbing, okay? This one, log of x by m equal to log of k into p to the power n. This one a into p formula. Therefore, log of x by m we can write log of a plus log of p to the power m. Again we know what? Log of e to the power x equal to x log of, you know. That's why you can write this one 1 by n into log of p. Okay. Now if you just assume this one is a equation of a straight line, then we can get this one is y equal to this one m, this one x plus c, and this one is the y-axis, this one x-axis, m is the slope, and c is the intercept. Now, if you want to draw the graph from this above equations, we can. That is why, no, that means here log of x by m, x is what? Log of p. That's why log of p. C is the intercept. That means log k. Suppose we are taking intercept this much. Log of k, then the graph is this way. Suppose 1 by tan equal to slope, isn't it? Okay. Next, now see, we have to assume two cases with the help of this equation. Okay. Just write this one, okay? You can take a screenshot and write. Now see. Case 1. When 1 by n becomes 0, if this term, okay? If this term becomes 0, then obviously the whole term becomes 0, no? 0 into anything equal to 0. That means we can say x by m equal to constant, no? K is a constant, log of k is another constant. See, that's how we can say x by m is a constant. X by m is a constant. That means, what you can say from this above equation, that means the absorption is independent on pressure when 1 by n becomes 0. Okay, the absorption isotherm is independent on pressure. Next, second case. Case 2. When 1 by n becomes 0, then this term is now 0. Then obviously this one equal to log k plus log of p, no? From that, as you know, k is a constant. That means we can say x by m is proportional to p, no? Why? Because we are not taking log, okay? We are not taking log. We are just writing the relation. How the gas of absorbent is varies with temperature. X by m is proportional to p. Why? Because this one is a constant. 1 is nothing. 1 into anything is anything. That's why x by m is proportional to p. Now, what do you mean by proportional? Proportional means as we increase the pressure, the absorptions will increase. This means. Now, what the statement? That means adsorption varies with pressure. Directly, no? Directly. Okay? Now, Friendly's Isotherm had some limitations. Okay? Now see. How? As we got, this one is the Friendly's adsorption isotherm. Here is suppose log of x by m, log of p. Here is the log of what? K. This one is the slope equal to 1 by 8. Now this should be a straight line, no? As our equation is a straight line equation, but experimentally found that at a higher pressure, okay, at the higher pressure, the adsorption curve just comes this way. That means become parallel to the x-axis, that means log of p-axis. Why? This is the main fault of Friendly's adsorption isotherm. According to his theory, the curve should be increasing order. Should be this way, no? But actually, experimentally it is found that the curve, after some time or after some pressure, it goes to parallel to your x-axis. And this point is known as saturation point. Saturation point. Now, what is the meaning of saturation point? अभी समझो saturation point का meaning क्या है? Suppose हमने 5 ग्राम O2 लिया. O2 is a gas. हमने adsorb किस में करने के लिए दिया? चारकोल. चारकोल का कितना ग्राम है? सपोज 20 ग्राम चारकोल है. तो रिएक्शन टाइम स्पेन हो रहा है, रिएक्शन हो रहा है, लेकिन कुछ टाइम के बाद ये चारकोल 20 ग्राम तो खत्म होने वाला है ना, खत्म होने वाला है. जब ये 20 ग्राम खत्म होने वाला है तो वो वापस या फिर से ये ऑक्सीजन गैस वो एब्जॉर्ब कर पाएगा? ऑब्वियसली नहीं कर पाएगा, बिकॉज जब वो 20 ग्राम का जितना कैपेसिटी है इसका एब्जॉर्ब करने का, वो कैपेसिटी जब खत्म हो जाएगा, उसी सिचुएशन को बोलेंगे हम सैचुरेशन पॉइंट, क्योंकि वो सैचुरेट हो गया, मतलब पूरा कंप्लीटली वो एब्जॉर्ब कर लिया है, उसका और कैपेसिटी नहीं है कि वो वापस से फिर से किसी गैस को वो एब्जॉर्ब कर पाए. एंड इसी पॉइंट को बोलते हैं हम लोग सैचुरेशन पॉइंट. इस सैचुरेशन पॉइंट में हम लोगों का कर्व स्ट्रेट होने के बजाय ये एक्स एक्सिस की तरह पैरेलल हो जाएगा. यही है मेन लिमिटेशन और यू कैन से फॉल्ट ऑफ Friendly's adsorption isotherm. Okay? How can I write this one? See. Main statement. Okay? At high pressure, the Friendly's adsorption isotherm, FAI, Friendly's adsorption isotherm fails. Why? As at high pressure, the curve becomes parallel to log of p, that means x-axis due to saturation point, or you can say direct saturation. Okay. Till this much we are explaining or we are talking about the how gas is adsorbed in the liquid or solid. till now we are discussing about how gas is absorbing in the liquid or solid. Okay, but now we are discussing about the adsorption from solid phase. That means in the adsorption process is going on in the solution phase. Solution phase, that means liquid phase. Okay, now see how. Here are the three examples. Here are the three examples. First one. One part of acetic acid is absorbed when we add the acid and shake with charcoal. Suppose here is a acid solution is there. Okay, when we add charcoal, the concentration of acetic acid in the previous case, that means what? That means before the reaction, what was the acetic acid solution? This decreases when we shake this acetic acid with the charcoal. That means what? Some amount of this acetic acid is adsorbed on charcoal, no? That's why the concentration of acetic acid when we shake with charcoal decreases. That means acetic acid is absorbing on the charcoal. Okay? Now, next example. Color of the litmus solution disappears when it reacts with charcoal. As you know, the color of the litmus solution is little bit dark purple. Okay? Now, when we react or when we add charcoal in litmus solutions, the color of the litmus solutions disappears or colorless. Okay? That means we can say the litmus solution is absorbing on the charcoal. Third case is the when magnesium hydroxide attains blue color when precipitated in the presence of magnesium reagent. Magnesium is a solid reagent. Okay? Due to the adsorptions of magnesium hydroxide on magnesium, the color of the solutions become little bit blue. Okay? These are the three examples of the adsorptions on solution phase. Okay? Next, from this example, no, we can conclude some important points. Now, what are the points we have to know? Okay? First point is the first point. Very important point. Okay? First point. The extent of adsorption. Actually, adsorption decreases with increase in temperature, as I explained earlier. Okay. Second statement or second important point is the extent of adsorption, okay, increases with increasing pressure. Okay. Third is the extent of adsorption increases, okay, with the increase in the surface area of adsorbent. How? We have to know how. Suppose let us take an example of adsorbent. This one, adsorbent. Now here is another adsorbent. The surface area of adsorbent in this case is higher or more than this adsorbent. Now if we are adding some gases as a adsorbate, then obviously here also, obviously due to the large surface area, the more number of oxygen molecule are adsorbed in this surface, no? But here is due to the less surface area, the absorption of the O2 on that adsorbate is low. Okay? Next statement. Next point is the extent of adsorption. Okay? Depend on the concentration of the solution. If the concentration of the solution is higher, then obviously it can absorb more number of solute or more number of adsorbate. No? Yes. That means the extent of absorption depends on the concentration of the solution. If we are giving less concentration solutions, then adsorption will be low. If we are giving more concentrated solutions, then the adsorption obviously will more. Next, and the important point is the extent of absorptions depend on the nature of both adsorbate as well as adsorbate. Okay? Depending on this nature of the adsorbate and adsorbent, we can see the absorption process varying. Now, you can know? Now. Next. Next thing is the Fenlow's adsorption isotherm little bit modified. Okay? Fenlow's adsorption isotherm is little bit modified as Fenlow's adsorption isotherm is modified as x by m equal to k c to the power 1 by n. Okay? In presence of pressure, next thing or next section, Fenlow's introduced C. Okay? For C is the concentrations of the what? C is the concentrations of the solutions. This equation, that is the new equation, is okay. By this equation, the new equation of Fenlow's adsorption isotherm is equal to x by m equal to k c to the power 1 by n. Using these equations, we can show the validity of Fenlow's adsorption isotherm, where x is the difference in the initial and final concentration of the adsorbate solutions. Okay? Using the above equation, Fenlow's, okay, above equations, we can show the validity of Fenlow's adsorption isotherm, where x is the difference in initial and final concentration of what? Of adsorbate solutions. Okay? Now, next. Then, Next is the application of adsorption. This one do yourself homework. Okay, in their book directly it is written more than 8-9. Okay, more than 8-9 application is there. Just 3 or 4 applications. Okay, this one is homework. Okay.